Hello class, today we are going to be doing the notes for 7.3, rectangles, rhombi, and squares. Be sure to begin at the top of your paper by initialing your 3 preliminary steps for note taking. Okay, now let's do, with quadrilaterals, we have what is called the families of quadrilaterals. You have your just basic four-sided figures, right? Then some other special ones that we've talked about are trapezoids. Then we have kites and parallelograms. We'll put kites over here. And what we want to focus on today are special types of parallelograms. So, parallelograms. First, what are the 4 characteristics that we know about parallelograms? First, both pairs, opposite sides, are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. And then diagonals bisect. Okay, once we've determined that something is a parallelogram, then there are special types of parallelograms. We have those that are equal angular, and those that are equilateral. Okay, equilateral, that means the sides are all the same length. So that would be like a rhombus. Rhombus. A rhombus is a parallelogram that is equilateral. Equal angular, if a quadrilateral is equal angular, what are the measurement of its angles? 360 divided by 4 gives us 90 degrees. So if it's equal angular, that is a rectangle. Okay, so ways to prove that something is a rectangle. First of all, if a parallelogram, so first you've shown that it's a parallelogram, or you're given that, has congruent diagonals, then it is a rectangle. So there's something special about the diagonals. So we already know that the diagonals bisect. So that means that all 4 of those segments are going to be equal to each other. Or you can also, it's sufficient just to know that AC is congruent to BD. Now, a rhombus has something special having to do with its diagonals as well. So if we know something is a parallelogram, has diagonals that intersect, or let's actually just say that are perpendicular, then it's a rhombus. So here's our parallelogram, and in a rhombus, the diagonals are still bisect each other, but the important thing is that they meet at a right angle. And I'll put an R in there. So that means that angle ARB is a right angle. All right, so notice that with each of these, they have something that's equal and something that is at 90 degrees. In a rectangle, the opposite angles, all the angles, internal angles are 90 degrees. Those are right angles, or they're perpendicular. In a rhombus, the diagonals are perpendicular. And in a rhombus, the sides are all equal to each other. In a rectangle, it's the diagonals that are equal to each other. So those are the things that are special about those quadrilaterals. So another way that you can prove that a parallelogram is a rectangle is if it has a right angle. So if a parallelogram has at least one right angle, it is a rectangle. That's going to be helpful with proofs, both two-column proofs and coordinate proofs. All right, now, if a parallelogram has at least two consecutive sides, so that's next to each other, congruent, then it's a rhombus. Okay, so those are rectangles and rhombuses. Now, I've run out of room on my paper, but maybe you have room on yours, maybe not. We haven't talked about squares yet. What do we know about squares? Squares are, so here we have our rectangle, and here we have our rhombus. Okay, rectangle, rhombus. Well, we know that a square has all four sides equal to each other and right angles. So a square is both a rhombus and a rectangle. So if a parallelogram is both a rectangle and a rhombus, it is possible to be both, then it is a square. What that means for us is that to prove something's a square, we have to prove that it's a parallelogram, we have to prove that it's a rectangle, and we have to prove that it's a rhombus. And once you've done that, you've proven that it's a square. In the next segment of this video, we'll do some examples.